Guys, welcome back to Chemistry TV. Let's focus on our Buffer solution. Our focus is going to be NDC Hesselbalch equation. So first, we have to look at how to derive the NDC Hesselbalch equation because if you are talking about biochemistry, acid and base, and Buffer solution, one of the questions that I want to ask you is to what derive the NDC Hesselbalch equation, and I can use that equation to what solve problem when it comes to what Buffer solution. So NDC Hesselbalch equation is used to calculate the pH of a buffer solution. Just so when we talk about buffer solution, we talk about what solution that can resist change in pH when small amount of acid or base are added to it. So I'm going to create a complete video on the calculation aspect of what buffer was solution. Just so but first, we look at what is the indexable equation. Indexable equation is what is pH equals to what pKa plus log concentration of conjugate salt concentration of the acid. So this is the equation we want to derive. Just because we have to derive it in the exam. So please pay close attention here because I'm going to walk you through step by step how you can derive this equation easily. Just so by the time you see this kind of question, derive the indexable equation is more easier for you. So the first one to talk about here is that now when I talk about first solution, you're talking about what weak acid and what weak base. So now let's focus on the acid aspect. And the acid you have to use what is HA. Hi there, aqueous. Hi there. Now, when you dissociate this one in water or you split it here, you have to get what? You have to get H plus what? A what minus. Hi there. So here we have what aqueous and what and aqueous. Just that. So when an acid is called monoprotic acid, is what monoprotic acid. And what do you understand by monoprotic acid? These are acids that can donate only what one proton. So when we talk about the indexable equation, you are using what monoprotic acid. That is acid that can what donate one proton. So for polyprotic acid or for polyprotic acid is not needed. You understand? So we talk about monoprotic acid. So when you add this monoprotic acid here, we split, we go to have H plus equal proton. This A minus called the conjugate what base. Right there. Now, if you should also react to water, I want to show you something before we move on. If you react to water, HA plus what H2O. Just according to postulate concept here, acid donate a proton, while base accept what a proton. Do you understand? So this guy is acid, here is what is the base, water acts as the base. So what will happen here? Now, when some donate hydrogen that one, you're going to have what? H3O plus aqueous. Just like remember here is aqueous and here what? Right? Now, because it have donated this one here is what is acid, like what I say, here is what is base. Just so when you donate a proton here, it form what H3O plus. Now this will now form a base. Whenever a base accept a proton, it form what a conjugate acid. So here called conjugate acid. Conjugate what acid. Just now what we left is going to be what A what minus. Now here is going to be the conjugate what base. So whenever an acid donate a proton, it's going to form what a conjugate base. Conjugate what base. So acid produces what conjugate base. Base produces what conjugate what acid. By what acid what we donate a proton, by base what we accept the proton. Do you understand? Now these two reactions are ready to be the same. So this is the acid, this is what the conjugate what base of the acid. Do you understand? So we have to use this equation here. So the first step in deriving the indexable equation, the first step to derive the indexable equation is to write the acid equation. Do you understand? Which is this here. The next step I want to do here is to write the ionization equation or the law of mass action. Do you understand? So remember, in chemical equilibrium, when you have something like this, A plus B give you what C plus D, which called the law of mass action. Case equals to what? Constitution of C raised by A, the constitution of D raised by D, well, constitution of A raised by A, the constitution of B raised by B, right? This is called the law of mass action. You understand? They may ask you what state the what law of mass action. This is what law of mass action here. The concentration of the products raised by the coefficient over what concentration of the reactant raised by what coefficient. That is the product of what product of your constitution of the product raised by the coefficient over product of your constitution of the reactant raised by the what coefficients. Do you understand? So this is what we are going to do here. So what we want to do here is so what to write the equilibrium constant expression. I get equilibrium constant expression for this reaction here. Now here we are talking about acid, which is called weak acid. All weak acid have Ka. So going to be Ka equals what? Concentration of what? Of proton, but concentration of what? Of times concentration of what? Conjugate base, or what? Concentration of what? Of the acid. So now this is the first step. Step one. Here was step what? Two. Write what? The equilibrium constant expression. Just now for this what? For the what? For this equation here. Just now Ka equals what? H plus concentration times what? A minus what? Concentration over what? Concentration of the acid, right? Now the next thing we want to look at here is to ensure that you make this guy the Sawyer formula. Making this guy the Sawyer formula here. H plus concentration, making what the Sawyer formula. For you to make the Sawyer formula, you cross multiply, right? So going to be H plus A what minus equals what? Ka times what? Ha. Can you see that? So you divide both sides by what? A minus concentration, right? So if you do that here, you go to have what? A plus equals what? Ka times Ha over what? A minus. Do you see that? So that is H. The proton concentration equals what? The equilibrium constant expression for the acid, called acid dissociation constant, times what? The times concentration of the acid over what? Concentration of the conjugate what? Base, right? Now, but we want to do something here. Now, this is what you want to do here. You want to do it like this, arrange like this. H plus equals what? Ka times Ha what? A what minus. Do you understand? Because these two they are together here. So you just want to, and this guy and this guy that what? That the same thing. You get now, but it make more sense when we do like this. So the next one to do here is what? Is say what? The negative logarithm of both sides. So that yes, number 3, right? Number 4, taking minus log of both sides. Taking minus log of what? Of both sides. Taking minus log of what? Of both sides. So when taking minus log of both sides, you're going to do what? Minus log H plus, can you see that? Equals to, remember here we have two different components here, Ka and what? The whole of this one here. So don't let's get it as one. Just stand. So going to be what? Minus log Ka. Remember in logarithm, now whenever I use logarithm, multiplication sign will change to what? A positive sign. Do you understand? So when I take the negative log of both sides here, because you are involving log here, the minus sign here, the multiplication sign will change to a positive sign. So it will be minus log Ka here, right? Plus. Now this plus here is the great of this one here. Do you understand? So now remember the whole of this one they are together. So you have to what? Take log of them. So going to be what you want to do here. So we'll put square bracket here. Minus log. Here we have Ha what? A what minus. Do you understand? So now the main reason why you put square bracket here so that it will make more sense. Now because here and here they are different here, so you take negative log of this side here plus now minus log of the whole of this one here, so you just separate them. Do you understand? Now what I want to do here, so we'll say what? Minus log H plus equals to here minus log Ka. Now remember you have to open the bracket, right? When you open the bracket, plus times minus is what? Is minus. So it's going to be minus log Ha what? A what minus. Can you see that? That is it. Now, what you want to do here is that you want to change to what? To positive here. Just now change to positive. This one will go up, so will come down. So you want to have what? Minus log H plus equals to minus log Ka plus log. So this one move up, so going to be A minus over what? Ha. Do you understand? So you can see how easy it is, but we need to move to now. I want to do the last stuff here because here we have pH and pK. Because if you check very well, this one is this one here. Do you understand? Look at the plus here. So yeah, we have to what change to something here, pH and what pK. So this is the next I want to explain to you now. This is the next I want to explain to you. Now understand that pH is always equal to minus log what constitution of H plus. Do you understand? pH equals of minus log what H plus. That is what you want to what take note of. pH equals of minus log what H plus what concentration, and pKa equals of minus log what Ka. Do you understand? So with this understanding here, we have to write any asking minus log H plus concentration. I want to put what pH. So what do you pH equals to, now here I have minus log Ka. So what to be what, which what pKa plus, they have now add down here log A minus what Ha. So this is what the index about what equation. This is what the index is by equation. We have to derive it later. So next thing after your derivation here, how do you use to solve problems? So that's going to be our what next video. So you can check it out here. Yes, that's going to be our what next class. If you are not subscribed, please kindly subscribe to the channel. And if this video is helpful, please leave a comment section that this video is helpful. See you in my next video.